Hello, everybody. We're going to take a look at division with fractions, and we're going to put that multiplicative inverse to use. We're in Unit 2.3F of WAMAP, so second half of the term for most of you. Let's take a look at these division problems. We have 7/10 divided by 13/6 and 5/9 divided by 7/6. So let's take a look at those on my tablet. See if they look any better. All right, so 7/10 divided by 13/6. For division with fractions, some people say division doesn't even exist. It's because they use the keep, switch, flip method, which you can use too. Keep, switch, flip method. So keep means leave it the same. Switch means change the operation. So we're going to use the inverse operation. We've talked a little bit about that. And flip means you're going to turn you're going to use the inverse, the multiplicative inverse, or the reciprocal of the fraction that is the divisor. Okay. So that's a lot of kind of high-tech jargon that you can disregard. What we're going to do is say 7/10. We're going to change this to multiplication. And we're going to flip this around on its head. So we're going to rewrite this as 7/10 times 6/13. And then we're going to treat it just like regular multiplication. And another thing we might want to do, we've got a couple of prime numbers here, but these two can be divided by 2 at least. So why don't we take out a 2? See if my tablet will help me. 6 divided by 2 is 3. 10 divided by 2 is 5. Okay, so now we've got all prime numbers. So we got 7 times 3, 21, and then 5 times 13. So my magic rule, multiplication by 5, take half of 13, that's 6.5, and we multiply by 10, or we add a 0, but we're going to move that decimal point over one place to the right and make 6.5 65. So we already know that we used only prime numbers to create these numbers, so we know that they are composite numbers, but they don't have any factors in common. We used 3 and 7 to create this one, and 5 and 13 to create this one. So this is as far as we need to go with this problem. Okay. Let's try the next one. 5/9 divided by 7/6. We're going to do keep, switch, flip. And that means we're going to write 5/9 times 6/7 and then multiply that out. And I hope you guys are watching for numbers you can produce. You can factor down before we do the math. Let's take out a 3 and leave 2, and take out a 3 here and leave 3. And so we divided the 6 by 3 and got 2, and divided the 9 by 3 and got 3. So now we have all prime numbers here again, so we shouldn't have to reduce when we're done. 5 times 2 is 10, and 3 times 7 is 21. 10/21. No common factors, so we are done. I want to show you something. We know that, say we wanted to say 10/1 divided by 2, something like that, right? So if we were to use the keep flip method, we're going to leave 10/1 where it is. Let me change colors once just for fun. We're at 10/1 times the inverse of 2. This is 2/1, so 1/2. Okay, do you see where I'm going with this? 10 times 1 is 10. 1 times 2 is 2. 10 divided by 2, this will give us 5/1, which is 5. So when you say 10 divided by 2, which is what we have here, 10 divided by 2, it's the same as saying 10 multiplied by 2's inverse, which is 1/2. And we can see, whoops, I'm in the way of my own answer. There. Can you see that? The secret answer, the reveal. Yeah, so this shows how this works. We wanted to divide 10 by 2, right? 10/1 divided by 2. So we used the inverse of 2 and multiplied. And when we did 10/1 times 1/2, or 1/2 of 10, we ended up with 5. So that's one way to show easily that this system works. Okay. So if it's a struggle, just remember keep, switch, flip, and you're going to use the multiplicative inverse and the inverse operation, and those two inversions keep everything basically the same as it was. Okay, so give it a try. If you get stuck, message me from inside WAMAP.